Okay? So what's the first step to solve these? What do we need to make sure before we just go ahead and square both sides? Isolation. Yeah, make sure that this radical is completely isolated. It's just that guy on one side, and we check that. In fact, it is. It's just the radical on one side. So now we can go into the step that you mentioned first, which was squaring it. So let's go ahead and square this. So we'll square both sides. So this guy squared is equal to x minus 1 squared. Now the squaring undoes the square root. So we have 6x plus 1 is equal to, now this guy squared, I'm going to go ahead and do it the long way just to avoid making a mistake. And so we have 6x plus 1. Now this guy, if we go ahead and FOIL these two, x times x, right, x squared, x times negative 1 times x, negative x, and negative 1 times negative 1 is positive 1. So be careful on this. We don't want to make a mistake. We don't want to make a mistake at all, but definitely here it can be easy to make a simple mistake. Let's avoid doing that. We continue this up here. I'm going to simplify the right-hand side. So we have 6x plus 1 is equal to x squared. Negative x minus x is negative 2x. Now we can clearly see that we were at a quadratic here, but now it's even more clear. And so from here, set equal to 0. So I like this guy to be positive. It's a coefficient, so I'm going to subtract 6x from each side, and I'm going to subtract 1 from each side. Okay. By doing this, I have 0 equals x squared minus 8x, and then this goes away to nothing. So we have 0 equals x squared minus 8x. And then now the next step is to factor like we normally would. So 0 is equal to, what's the greatest common factor of these two? Okay, so I could factor or quadratic formula. So the greatest common factor is x, leaving me x minus 8. Yeah. So then x could be equal to 0 or positive 8. And I need to test these. Excuse me. These here? Oh, so this was factoring. So the step from here to here, the step from here to here, whoops, from here to here, I just took out the greatest common factor. I factored. I noticed the greatest common factor of these two is x, and factored that. So let's go ahead and test these. Some of you might already get this, but let's just be respectful for others, please, and let's be quiet, especially while I'm talking. So we're going to test these two. So let's see if it works for, let's say, go ahead, let's do 0. So we're testing. We're testing our proposed solution. So if we test it, we have the square root of 6 times 0 plus 1. Does that equal to 0 minus 1? So we have the principal root of 1, does that equal -1? The answer is no. Remember, this is just the principal root, right? It's not specified plus or minus. It just says the principal root of 1. So this is not true. So we'd say, okay, this is not true, so this doesn't work, so therefore 0 is not an actual solution to this original equation. And then now let's go ahead and test the other one, where we have the square root of 6 times 8 plus 1. Does that equal to 8 minus 1? And we have the principal root of 49. Does that equal 7? And yes, 7 does equal 7. So we get to check. So this does work. So our only solution would be x equals 8 for this original equation. What? Your voice. What's that?
I'll check double.
Do it. Do what? Alright, so what about the time on this?
Yeah, it's so it was 8. I knew. We have homework for this week. So can you give us start giving us like a worksheet?
Yeah. We'll probably look at some more of these here. So look at this. All right. So which of these would you guys like to look at? 26 it is. 26 we have all right, so this is one of the double radical problems. What would be the first step for this? Isolate one of them, right? Doesn't matter which.
X and negative
Isolate.
It don't matter, but yeah, just isolate.
Right. Well, I'm gonna add this guy to both sides.
Yeah, that makes sense.
That way, that he remains the same. He remains the same sign, positive 1. All right, and let's go ahead, and the next step would be to square both sides. So if I square this side and I square the right-hand side, if I square the left-hand side, I would simply just have 2x minus 3. And when I square the right-hand side, let's do it the long way so that we know we don't make a mistake. Alright, so if we do this, see what we get. Now this is where you don't want to make a little mistake, so let's be careful here. So we have the square root of x minus 2 times the square root of x minus 2. That simply is just x minus 2. Then we have the square root of x minus 2 times 1, so plus the square root of x minus 2, plus 1 times the square root of x minus 2, which is still square root of x minus 2, plus 1 times 1, which is 1. Yes? You sticker writing?
Yes.
Sticker? Yes? Okay. Is that better? That's a lot better now. Alright, so continuing this problem over here, we have 2x minus 3 is equal to,
With the writing back small.
now when we simplify, I did, I apologize. You're right, you're right. I did.
With the writing back small.
So, 2x minus 3, what does the right-hand side become?
Null and void.
Null and void. I don't think so.
It counted, they counted.
What cancels?
Oh no, combine like I don't know how he been, we've been talking all day. In my ear.
There's a lot of talking going on, guys. I don't know why you guys are talking
Put your
while I'm
foot
talking.
down, Mr. Broken.
Yeah, guys, stop talking.
My dog.
Why are we talking right now? Why are we talking right now? Even if you're explaining something, the thing is, I hear that while I'm trying to talk. I appreciate for those of you that are actually working on math, but I can't even hear myself think, and being rude to other students that are trying to focus on this. So let's not talk while I'm talking, and when another student is showing something up front, let's not talk while that student is talking. So what does the right-hand side become?
Okay, so we have this middle, if you add, would it be like x minus 4?
Let's see if we can find like terms. This is a constant term, -2. And this is also a constant term. Okay. Any other like terms? This and this. And that's it, yes. This x is the only term that's like itself. So if we do this, what would we get then if we combine like terms? We do it all in one step. Uh-huh.
And then for the other one, I don't know. I don't remember if we keep it forever.
Okay, so here's the idea when we think about addition. We have something, okay? Even if you didn't know the name of it, you have this thing here, and you're adding another one of those exact same things. So you can keep the principle very simple in your mind. If I have, let's say, a pencil plus one more pencil, is that 2 pencils, or is that 1 times 1 and 1 pencil? What is that?
Don't pick me, pick me,
Yes.
pick me. Okay, so would it be 2 times the square root of x minus 2?
Very good. So you have 2 of them. 2 times the square root of x minus 2.
Mr. Groves, do
Yes.
you boil it?
I have not pulled anything, no. We're just combining like terms.
Oh, so you put that there, but you just broke it down. Basically.
We got -1 from adding -2 with +1.
Well, you get x. How do you get all that? X subtract 2.
Okay, so again, guys, I'm just combining like terms here.
Yeah. Yeah, I understand that, but you got 3.
Yes.
What?
Yeah, so I'm not done yet. So I just want to make sure we're all comfortable that -2 plus 1 is in fact -1. And the square root of x minus 2 plus the square root of x minus 2 is 2 of those. So 2 square root of x minus 2. And we still have this x. So that's still there. That didn't go anywhere.
How do you write that instead of 4?
How do you do what?
How do you write it in like the proper form, standard form, or whatever it's called?
Well, there is no standard form for this. So you notice we now have a single radical equation. So now we have to repeat step 1. And what was step 1?
Isolate
Isolate
the radical.
a radical, yes, yes,
Still not understood.
yes.
When you started before that, when you did all of the x subtract.
Here? I got this because I FOILed. So the square root of x minus 2 to the square root of x minus 2 is x minus 2. Guys, I can't even hear her talk. Yes? How did I get this x? This x came from when I did the square root of x minus 2 times the square root of x minus 2, you just get x minus 2.
So to get that over there, what you just combine the x, subtract 2 squared, you combine them to get.
So to get from this step to this step, all I did was as I simplified, I combined like terms.
So you combine x, the square x minus 2. And what can you do?
Yeah. So we have this line here. You want me to start here or start here? Here? So I have this, and all I'm doing is saying, well, I see there are like terms here, so let me combine them. I see there's a -2 and a 1. Those are constants. I can combine those, yes.
Oh, you can finish explaining because you told it.
Okay. And I can then combine these two because they're the exact same thing. Right? No matter how complicated something looks, the fact is, these are the exact same thing. So I would have 2 of them. Right? What's one textbook plus one textbook? 2 textbooks. It doesn't matter how weird it might look on paper. The fact is, I'm one of something plus one of the same something. It is 2 of that something.
What do you got?
The -1 is what we get when we have -2 plus 1.
It's two, it's that.
The 2, there's 2 of these.
Oh.
That's what he messed up.
And then the x is still there. There's nothing that, the x didn't combine with anything, so it's still there. Yeah, you can put it anywhere. Yeah, order doesn't matter for addition, guys, right? Commutative property addition, order doesn't matter. So then now from here, what would be the next step? Can someone tell me? Or you had a question?
That goes with my question. Okay, so before we isolate, would we put the 2x minus, like, if we move that over?
You mean set this equal to 0?
Yeah, well, we set it equal to 0 and then isolate, or isolate?
No, just isolate.
Just isolate.
So you're looking to get this guy, we are looking to get this, just this part here by itself, just the square root of x minus 2 by itself. Yes?
So with the 2 in front of the article, do we just divide them? Once we...
Eventually, so we're isolating. So when we isolate something, yes? Never mind? Okay. All right, so let's move forward here. How do I get to isolate? So when I isolate something, basically it's kind of we're working from the outside in. Working from the outside in. What's furthest away from the square root of x minus 2 on the same side of the equation? The 1, the -1, or the x, but definitely not the 2. The 2 is closely connected by multiplication, so let's work on the elements that are farthest away. What's that? We already did something? What did we do? Okay, so I'm going to isolate this guy. So I'm going to look at, okay, I have this -1 and this x connected farthest away. So I'm going to add 1 to each side, and I'm going to subtract x from each side. I'm doing the same step just to get first off this guy by itself, and then finally, last but not least, I'll divide by 2. So when we do this, 2x minus x is just 1x, and -3 plus 1 is just -2. And then now I'm left with 2 root x minus 2. And then now the next step, guys, would be what?
Divide by 2.
Divide by 2. We could even square it the way right now if we wanted, but I'm going to divide by 2. I'm sorry, just 1 second. And let me go ahead and do this so it's clear. All right, so then we have x minus 2 over 2 is equal to the square root of x minus 2.
Divide.
Why don't the,
Is there a question? Yes.
okay, why don't the 2's on the left cancel?
So if we wanted to break this up, we could. We don't have to, but we could. All right.
So wait, if you do decide to break it up, would it be x minus 1?
If we broke it up, remember we have to break up each part over the original denominator, so it would be 1/2 x minus 1.
Oh, no.
If you decide to break it up, we don't have to though. We don't have to. Let's go ahead with, see if we can actually take the whole thing over. So yeah, someone said something about squaring it, and we're on the right track there. Can you guys still see that at that level? How's that?
Don't make it.
Is that okay? Is that about as small as I'll also go that small? All right, so now continuing from here, what would be the next step? Square both sides, that's correct. So if we square both sides, so let's be careful here when we square both sides. It may be safe for you guys to just do this. Now, we did not have to divide by 2. If you wanted to square both sides from there, you could be perfectly allowed to do that. That's fine as well. There's one way to do it. But you would arrive at the same thing. So continuing here, if we do this, if we FOIL this, if you imagine x minus 2 times x minus 2, you would have,
Would it be x minus?
what's that?
Would it be x?
So you have x squared minus 2x minus 2x, which is minus 4x. Negative 2 times negative 2 is positive 4. All over 4 is equal to x minus 2. So then adding, and then now you want to get this set equal to 0. So if we get this set equal to 0, if we set this equal to 0, we can add x, we can subtract x and add 2 to both sides.
Yes, subtract x and subtract 2. Add 2.
So minus x plus 2, minus x plus 2 on this side. So x squared minus 4x plus 4, all over 4, minus x plus 2 equals 0.
Hold on. Oh, we'll put it in like that. I thought we put it in a fraction.
Yes. Yes. Yeah, exactly. I would do that too. I would go ahead and multiply something by 4, and then we get rid of the fraction. We could have done that from right here, we could have squared both sides. As long as you're careful with your work and you're doing what you need to do to both sides, get equal to 0, it doesn't matter how you do it, yes.
I thought we had just added into the top of the fraction.
Well, these don't have a denominator of 4.
So we can't put it into the fraction like x. We couldn't do x subtract.
In fact, I know some of you have already done it this way. You can do it this way, but I've already spotted something a lot easier. It's probably be more simple to understand. I'm going to go all the way back to here. I'm just going to square both sides from there.
So
Just to avoid this fraction here.
So
Just to avoid it. Yeah, so I'm going to go back to this line, and I'm going to square both sides. So pardon me for those of you that have written notes up to this point. You can continue this path, but it would be much easier just to square both sides from there. So let's go back to there. This is why we have big erasers in math. There's nothing wrong with what I've done. It's probably easier just to go ahead and square both sides from here. Well, so we saw that path, and there's nothing technically wrong with it. It just seems like it's a lot of unnecessary work. So let's go from here. Let's just square this. If I square this and I square this, now let's be careful here. We would have the left-hand side would become, if you FOIL this, you'd have x squared minus 4x plus 4 is equal to 4 times x minus 2.
So you just times,
So again, I'm doing a shortcut. Again, if you still don't get a shortcut, which I understand, just do it the long way. X minus 2.
I thought it was a fraction.
No. I went back to this line and I decided to square it to avoid the
I thought it
fraction.
was a fraction. Oh, you took the fraction off?
Yeah, we went all the way back to this line here. X minus 2 is equal to 2 times the square root of x minus 2. So then x squared minus 4x plus 4 is equal to 4x minus 8. And then set this equal to 0. So x squared minus 8x plus 12 equals 0. And then if you can factor this, factors of 12 that add negative 8 would be negative 6 and negative 2. So we have two possible scenarios here of x equals 2 and x equals 6. Yes.
I just look at my mouth.
And then we got to remember to check these. You have to check these.
Well, you just did it tomorrow.
What's that?
Tomorrow.